Okay, looking at soil fertility and plant nutrition. So plant nutrition is the need for basic chemical elements for plant growth. Fertilization is the application of plant nutrients. So nutrients may be applied as commercial manufactured fertilizers, organic fertilizers, or other soil amendments. Organics are typically very low in nutrient content. And so you can see on here we've got a 1-1-1. 1 is 1% nitrogen, 1% phosphorus, and 1% potassium. So plants need 17 elements for normal growth. Carbon, hydrogen, and oxygen come from air and water. And then soil is the principal source for the other nutrients. So the primary nutrients are nitrogen, phosphorus, and potassium, and all fertilizer bags have to have these numbers on the bag. And so we have 10, 20, 20, so that means we've got 10% nitrogen, 20% phosphorus, and 20% potassium. These primary nutrients are used in relatively large amounts, and they're usually are often supplemented as fertilizers, and in some cases not necessary. Secondary nutrients, calcium, magnesium, and sulfur, they're used also in fairly large amounts. Typically they're readily available in an adequate supply. Here we've got dolomitic lime, and that is actually both magnesium and calcium. And the only reason you would use this would be if you had both a calcium and a magnesium deficiency. So the micronutrients are needed only in small amounts: iron, zinc, molybdenum, manganese, boron, copper, cobalt, and chlorine. So last week we had cation exchange capacity. Hydrogen ions are actively transported out of the vacuoles of the root cells and into the soil. And then the hydrogen ions will actually displace the minerals that are adhering to the clay particles, and then those are diffused into the root. So mobility of nutrients in plants, we've got nitrogen, phosphorus, potassium, and magnesium are mobile. And then immobile, boron, calcium, copper, iron, manganese, molybdenum, sulfur, and zinc. And it's important to note that phosphorus, you will see in some readings it'll say that it's immobile. It's immobile when it's in the soil. So that's why in many cases mycorrhizal fungi will be needed to get to it. But once it's in a plant, it is mobile. And we'll talk about what that looks like soon. Okay, just letting you know, nutrition just means the availability and the type of chemical elements in the plant, and then fertilization is adding nutrients to the soil. So essential nutrients, in the absence of that element, the plant can't complete its life cycle. And you can see with the green and the blue, those are essential elements. And then the other things are beneficial. But there's quite a few things that are necessary for a plant to complete its life cycle. Okay, so this is the law of the minimum. If one growth factor or nutrient is deficiency, plant growth is limited, even if all the other things are adequate. Plant growth is improved by increasing the supply of the deficient factor or nutrient. Okay, so you're going to be looking at these things when you're, hopefully when you're figuring out what needs you might need for your soils. So mobile nutrients are going to show up, the deficiency is going to show up in the lower leaves because the nutrient is going to go to the new growth first. And so you can see here, nitrogen, phosphorus, potassium, magnesium, the lower foliage is showing some damage, and so that means that those are mobile. Immobile nutrients are going to show up on newer leaves or younger leaves. One of the biggest ones we get around here is iron deficiencies. And that happens when the soil is too high a pH for the plant. Rhododendrons in particular, quite often they're planted next to lawns, and lawns need a pH of 6.5, and rhodies are going to want to be below 6. So what will happen is that'll increase the pH of the soil, and then the iron is unable to go throughout the plant. So nitrogen is amino acids, our DNA, RNA, chlorophyll, and plants are 1 to 5% nitrogen by weight. So the forms that are taken up are ammonium cations and nitrate anions. You can certainly have too much of a good thing. So nitrogen will stimulate vegetative growth, and what that'll do is just increase soft tissue for insects. It'll increase photosynthesis, it'll delay maturity. As I said, succulent tissue that insects such as aphids are going to really enjoy, and then nitrate accumulation in the tissue, which is not a good idea. So as I said, nitrogen is mobile in plants, and old leaves are going to show the damage first. So you're going to see stunting, yellowing, chlorosis of older leaves first, and then chlorosis may begin around the midrib. Now the thing about this to note is sometimes with nitrogen the entire plant will just have an off color. So stunted growth, pale green to light yellow. So you see here we've got a plant that's got yellow lower leaves and green new leaves, and that's because of nitrogen deficiency. Okay, so sources of nitrogen. Of course, we've got our nitrogen cycle that we've talked about, but when we're talking about industrial fixation, which is where some of this the synthetic fertilizers come from, they bypass this whole situation. And of course we know about lightning, and here's our legume cropping system, and there's our nodules on our plant material. So synthetic fertilizers often used, you're not going to see ammonium nitrate anymore because that's what was used for bombs back in the 80s, so they stopped having it available. Ammonium sulfate is used a lot for turf, so that's 20% nitrogen. The thing to note is when a plant needs nitrogen, it'll take up what it needs, and then whatever is left will just be leached out. So it's really important that we don't use super fast release fertilizers or high percentage fertilizers. Now if you're going to do legume crops with sweet clover, that will add 100 to 120 pounds of nitrogen per acre. Red clover 40 to 60, and soybeans 15 to 60. So some of the sources of nitrogen, so manure is 1200, that means it's 12% nitrogen, 0 phosphorus, 0 potassium. And here are the different types. That's cow manure. So chicken manure has some of the highest percentages of nitrogen. So it's really important to know your sources. The other thing that's really crucial is that if you use manure, it has to be composted because it's got a very high ammonia concentration and it will burn plants. Okay, here we've got blood meals, 1300, fish fertilizer, 511, so 5 parts nitrogen, 1 part phosphorus, 1 part potassium. Feather meal, that's a really great fertilizer. Bat guano, 731. And then if you're going vegan, we have soybean meal. This is alfalfa meal on the top there. Cottonseed meal. Now, this is vegan, but the thing about it is that many sources of cottonseed are not organic. So if you're doing organic gardening, you need to make sure that it's a good source of cottonseed. Okay, so composted soil organic matter is about 5% nitrogen. 1 to 4% organic nitrogen is mineralized each year. And will it supply all your nitrogen needs? Probably not. Nitrogen is the least available to plants and the most needed. So it certainly can help. And it certainly can help with cation exchange capacity because of the organic matter. But I wouldn't use it exclusively for your nitrogen needs. So it's really important to note that fertilizers will increase plant growth only if the plant is deficient and the nutrient applied and other growth factors are not limiting the plant, such as soil compaction, water stress or waterlogging, insect and disease problems, and weed competition. So here we have fertilizer. This is 453, 4% nitrogen by weight. And say you need 0.3 pounds of nitrogen per 100 square feet. So 4% by weight. If you had 100 pounds of the fertilizer, 4 pounds would be nitrogen. 4% is 0.04. Your soil test says you need 0.3 pounds of nitrogen per 100 square feet. You divide that by 0.04 and that gives you 7.5 pounds. This is how much you need to apply to a 100 square foot area to get that 0.3 of nitrogen in that area. So should you use synthetic or natural nitrogen fertilizers? Well, plants don't really care where you get the nitrogen. They're going to take it up regardless of the source. And the thing is about the synthetic fertilizers, they typically have a high analysis, so that means that those are going to be very fast release, and as I mentioned earlier, those are going to be leached into groundwater if the plant doesn't use what you've applied. So it's a good idea to not do that if you can avoid it. So a natural fertilizer would be a 4-5-3. So that's 4% nitrogen, 5% phosphorus, 3% potassium. So one of the problems you have with synthetic fertilizers, they have a high salt index. And so that can burn roots, it can hurt microbes, it can leach, it can pollute, and it's not adding anything to the soil. It's not giving you any stable organic matter. Natural nitrogen fertilizers, they feed soil microbes, improve structure and tilth. They're naturally slow release. The thing is that when you are using these things, you need warmer soil temperatures because the microbes need warmer soil in order to actually start processing these fertilizers. They don't burn the roots, but some of them may attract vermin. And there are fertilizers that actually acidify your soil. And ammonium sulfate is notorious, and it's used a lot for lawns. It'll really increase the acidity of your soil, which is a problem with lawns. So if you're using an acidifying fertilizer on your lawn that wants a 6.5 pH, it's actually going to need to have calcium or lime applied to it to help neutralize that.